Now, acids are a special class of compounds, an important class of compounds that require their own set of naming rules. Okay, and one of the things we'll notice when we look at some common acids like HCl and H2SO4, HNO3, HCN, H3PO4, these are all examples of common acids, and what we notice from the formula is they all begin with the element hydrogen. When hydrogen is the first element in the formula, this is an indicator that this compound is an acid. And we'll talk about acid-base chemistry in some length in the course, but for now we want to learn how to name these. Okay? And when we identify that we have an acid, namely that H is the first element in the acid, we need to distinguish between two general classes that have very different naming rules. Okay? Our first class are those that do not have oxygen in them, and we're probably familiar with the common acid HCl, which is hydrochloric acid, right? And so in naming these acids, we identify the anion, in this case chloride, and we replace the IDE with an IC ending and add acid, and put hydro in the front. So HCl is hydrochloric acid. We might have HCN. Here our anion is cyanide, and we would name this hydrocyanic acid. Okay, and so the rules for these simple acids are pretty straightforward. If the hydro is present, there is no oxygen. Now, if there is oxygen present, we have to then identify what anion is part of this acid. That is, over here this is phosphate, here is nitrate, here is sulfate. So if it's an ATE ending, we are going to change that ATE to IC, and we are not going to include a hydro in the beginning of the name. So for example, a simple one here, HNO3, our base is nitrate, and this will simply be nitric acid. If we had HNO2, now we're no longer talking about nitrate, we're talking about nitrite. And when we have the ITE ending, we change that ITE to an OUS ending. So nitrite, excuse me, becomes nitrous acid. Okay, so we'll go over these rules a little bit more. Okay, so all of the acids that we will be considering contain the H plus cation and some anion, and we need to distinguish between those that do not contain oxygen and those that do. Okay, and here are some of our common simple acids. HF is hydrofluoric acid, and hydrochloric acid, hydrobromic, hydroiodic, hydrocyanic, and hydrosulfuric. Again, the hydro here indicates that there is no oxygen present. Now, it turns out that there is a different designation when these compounds are in the gas phase, and we do not want to be concerned about this separate set of rules. Whenever we see hydrogen as the first element in a compound, we are going to recognize it as an acid, and we are going to name it as the acid. So strictly speaking, the rule is that these are named as acids only when they are dissolved in water, that is, when they are in aqueous solution. But we're always going to name them as the acids. Now, for our oxygen-containing acids, these will always contain a polyatomic anion with an appropriate number of hydrogen ions present. Okay, and so here's some examples. And again, the rule here is we need to identify what that polyatomic oxyanion is. That is, what is its name? Is it an ATE ending or an ITE ending? So if it's HNO3, we identify NO3 as NO3 minus as nitrate, and we would name HNO3 nitric acid. So HNO2, having one fewer oxygen, is not nitrate, it's nitrite. So we would name this nitrous acid. 8 becomes ick, 8 becomes us. Okay, so H2SO4, We have sulfate with a 2- charge. Because this has a 2- charge, when we form the neutral acid, we add 2 H+ ions to it, so H2SO4. And SO4 is the sulfate ion, so this becomes sulfuric acid. Okay, H2SO3, again, SO3 also has a 2- charge and therefore always also has 2 protons in the acid form. And so sulfite becomes sulfurous acid. H3PO4, our anion is phosphate, PO4 3-. We have 3 protons here. This becomes phosphoric acid. Now, acetic acid is another example of these polyatomic acids. However, it's a little bit different in that this is an organic acid. And we will really not consider any other organic acids besides acetic acid. And in our course, we will always indicate that this is an acid by putting an H in the front. So the C2H3O2 has a -1 charge and is called the acetate ion. And so we call this acetic acid. Now, outside of this course, it's much more common to see this formula written differently. In fact, it's almost never written in this way. And so the most common form are these 2 green ones down here, CH3CO2H and CH3COOH, are more common designations. And it's really this COOH group that is what we call the acid group. And this is actually called a carboxylic acid group. Okay, but really acetic acid is the only example of this, and this is not a formula that you need to memorize at this time. So when we're naming acids, we need to distinguish between those that are oxyacids, that is, they contain oxygen, and those that do not. So if we see these 2 very similar names, bromic acid and hydrobromic acid, this hydro indicates that there is no oxygen present. And so this hydrobromic acid is simply HBr. Bromic acid indicates that oxygen is present, and the IC ending tells us that the anion present here is bromate. And then when we look on our table of polyatomics, we'll see that bromate is BrO3, and so our formula is HBrO3. Then we've got our chlorine oxides, right? We've got chlorate becomes chloric acid. We've got chlorite becomes chlorous acid, and hypochlorite becomes hypochlorous acid. Of course, we could also have perchloric acid. All 4 of those acids are fairly common. And of course, when we have HCl and there's no oxygen present, we add the hydro. So hydrochloric acid is very different from chloric acid, and we need to understand the rules for naming this important class of compounds.